Hello students, welcome to classroom. Today we'll be doing the second numerical problem from example 9.2, page 144. So the question is already written here. So let us read the question together and let's solve the numerical problem together. So first let us read the question once. An object 4 cm in size is placed at 25 cm in front of a concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. So reading the question is very important because it is only when you read the question you understand. Okay, so read the question thoroughly, okay, and try to get maximum information out of it. If once doesn't help, read twice, thrice. Okay. Now my suggestion to you is, after reading the question, whenever you're doing numerical problems on this chapter light, always identify the type of mirror first. So on reading the question, we come to identify that the mirror is a concave mirror. So on the corner of the page you can draw a concave mirror because that will be needed. Okay, every numerical problem we should supplement with a ray diagram that gives you more mark. Okay, so let us draw a concave mirror. So this will work for me, concave mirror. Okay, then draw the principal axis and remember to mark this dot. This is the pole. This is very important because every measurement that we will be doing will be done from this pole. All right, now let us write whatever things are given to us. So let us write given. Now what things are given to us? An object 4 cm in size. This is the size, this is the size of the object. Size of the object is represented by a symbol HO. So HO is given to us 4.0 centimeter. What is 4.0 centimeter? Don't get scared by the decimal, okay class? Decimals are just there to confuse you or trick you. And many students, you get scared with the decimal. Okay, 4.0 centimeter means 4 centimeter only. Simple, okay? Next, then an object 4 cm in size is placed at 25 cm in front of a concave mirror. Remember, object is always kept in front of a mirror. Okay, the object will always stand in front of the mirror. So this becomes the object distance. So object distance is represented by the symbol U. So U is given to us. It's 25.0 centimeter again, which will be written just 25 centimeter. Okay, we will come to the sign later on. Right now we'll just write whatever things are given to us. And then of focal length 15 centimeter. So focus is also given to us. It's 15 centimeter. So 15.0 centimeter, which will be written as 15 centimeter. All right. Then what else? From the mirror. Okay, at what distance from the mirror should a screen be placed in order to obtain a sharp image? So the question is asking you to find the image distance, which means we are supposed to find this. Okay, image distance. Okay, which is represented by the symbol V. Also find the nature and the size of the image. So nature also we have to find. So nature we'll have to find. Nature also we have to find. And the size also, right? So we have to find the size also. We will be finding all of these three. Now that we have the values, let us put these values into the ray diagram. Now my suggestion to you, whenever focal length is given to you, start with focus. Okay, so focus is given to me, so let me put the focus here. Let this be the focus. Focus is at a distance of 15 centimeter. So class, remember, this becomes 15 centimeter. You take this measurement with a scale and trace it and go and put it here like this. Okay, so this is 15. Okay, bring it back and start from focus, and wherever it ends, put a point there. This becomes your center of curvature. All right, this is the relationship which center of curvature shares with focus. Remember, the length of this line CP is known as radius of curvature because center of curvature is just a point in the center of the spherical mirror, isn't it? Okay, so remember that. Now this is 15 centimeter. So focal length is 15 centimeter. Remember class, this is 15 centimeter given the question. Now since we know focal length, we can also know the length of center of curvature. So let's find out how much will this be. So this is 15. Now this also is 15. So 15 plus 15 gives us 30 centimeters. That's how you can find out center of curvature. Okay, well, center of curvature was not given to us, but we need it, okay, to pinpoint where the object will be. So now done, focus and center of curvature has been labeled. Now object is at 25 centimeter. Now object is at 25 centimeter. So class, this much is 15, this is 30, so this is 30, this is 15. So the object will be between C and F, because this much is 30, the object is not, it's at 25, this is 30, so the object cannot be here, because if the object is at here, the object is standing at 30, but the question says the object is standing at 25. So this is 15, this is 30, so the object must be between somewhere here. Okay, so let us do something. This is 15, let's break into 3 divisions. 15, let's say this is 20, 25, 30. So the object, we will make the object stand at here. So this is where the object will be. Okay, the object is here. You can erase this one. Okay, too many points will confuse us, so C and F and object distance will do. Okay, now that we have pointed where the object will be, now let us take care of the sign Cartesian. Okay, before we go to the sign Cartesian, give a good look at the ray diagram. Does it ring a bell? It should ring a bell. Okay, it should ring a bell if you are thorough with the cases for the concave mirror. Okay, out of the 6 cases, if I ask you, to which case does this belong to? What is your answer? What is your answer? Case 4 is not. So this falls under case 4. Okay, now that you know which case it is, you can complete the ray diagram also. Draw one ray parallel to the principal axis, make it pass through focus, draw the other ray through focus and let it pass parallel. You'll get the image. The image you'll get somewhere here. Okay, because case 4, the image is from beyond C. Okay, beyond C. So you can complete the ray diagram. I will do it later. Okay, so now that we are done with that, let us have a look at the sign. Okay, we have to give sign to these values. So sign Cartesian. Now let us start from the focal length. So here, now to get the sign, my method is I always draw the direction of light. Okay, so the direction of light is this one. Okay, this is the direction of light. Direction of light. Now remember this, measurements done along the direction of light. That means, see, light is moving from left to right. So if the direction of our measurement is also along the direction of light, this will give us positive values. But if the direction of our measurement is opposite to the direction of light, this will give us negative values. Okay, now from where do we start our measurement? Our measurement starts from the pole, so this becomes very important. This is the very important point, pole. So we are here. Now we are here. What are we measuring? We are measuring focal length. So how are we going? We are going like this. Check out the direction of, our direction and check out the direction of light. Are we going along or opposite? Are we going along or opposite? We are going opposite, is not. So this will give us a negative value. So focal length will be minus. Then what about object? So we will be measuring like this. Are we moving along or opposite? Again, we are moving opposite. So minus. Okay. Remember, object is universal minus. Okay. Without doing that, you can just put minus, because object, whether it's concave mirror or convex mirror, it will always be minus. Okay. Now everything is done. We'll use the mirror formula and get the V. So using mirror formula, you write using mirror formula. Just write the mirror formula once. 1 by V plus 1 by U is equal to 1 by F. This is plus. Okay, this is plus here. 1 by V plus 1 by U equal to 1 by F. So put the values. 1 by V, V value we don't have, plus 1 by U, U is minus 25, is equal to 1 by F, F is minus 15. Put bracket here because plus and minus are together. 1 by V plus into minus, minus 1 by 25 is equal to, this will be minus 1 by 15, because denominator does not carry the sign. Next, what we will do, we will send this here. Okay, so let me just use this. So it will be here. Minus 1 by 15 was there from before. Let it be there. This will go there. Minus 1 by 25 comes here, becomes positive 1 by 25. Now what we will do, we will do LCM. So LCM, we will be taking LCM. So LCM is taken for the denominators. The denominators are 15 and 25. So those of you who are struggling with LCM stands for least common multiple. So select a timetable where you get 25 and 3. Okay, the smallest timetable. So the smallest timetable will be 5 here. So take 5 here. So 5 3s are 15, 5 5s are 25, then 3 1s are 3, 5 again, 5 will give us like this. Okay, so excluding this, you have to measure these values to get your LCM. So this is 5 3s are 15, 15 into 5 gives us 75. So the value is, the LCM is 75. Okay, now the sign will still remain same. So minus was here, it will be minus, plus was here. So all you have to do is sort out what number to come here, what number to come here. Now how do we do that? See, we have written the denominator. Now you go and look at the denominator. This is 15. Denominator with denominator. Okay, remember, denominator and denominator. What we will do is, we will find out 15 times how much is 75. So 15 times how much is 75? 15 times 5 is 75. Okay, so 15 into 7 is 15 into 5 is 75. Okay, so look here, 15 into 5 is 75. Okay, 75 is already there, 15 is already here. This is a new number. Okay, this new number will multiply with the numerator. So 5 will multiply with 1. What do you get? You get 5. So this is 5. Do the same thing for 25 also. 25 into how much is 75? So 25 into 3. Okay, so that's 3 will multiply with 1, gives you plus 3. Alright, so 1 by V. This is for those who are struggling with LCM. 75 is here. Plus into minus, minus. So 5 minus 3, 2. Negative number is bigger, minus will be here. Now we will do cross multiplication. Remember, this one, don't do this. This one, though, just to let you understand that because some of you are confused with cross multiplication also. So here I am showing the arrows to help you pair them properly. So V into minus 2. If at all you are do it with pencil and erase it. Okay, in the main exam, if you write like this, you will cut, maybe mark deduction will be there. So 1 into 75, which will be 75 only. So these two will go below 75. So V will be here. 75 already there. These two will go below. Minus 2 will go below. This negative sign will be brought to the numerator because denominator does not carry sign. And now we will divide and get the answer of V. So we divide this. So let me erase this one. And let's divide 75 by 2. So 2 3s are 6. Okay. Now 7 minus 6, 1. Then 15 here now. 2 7s are 14. 1 in hand, 0. So 2 5s are 10. So we got the answer to be 37.5. So the answer is 37.5. Do not forget the minus centimeter. So we have finally found the value of V. Okay, minus 37.5. Now let's check, is this correct? Now see, okay, now let me complete the ray diagram. So ray 1 will go like this, passing through focus. Ray 2 will enter through focus and it will go parallel. So we find that the image is, since the two rays they meet here, so the image will form here. So we can draw the image like this. Okay, so it's at 37.5. Now let's verify this. Is this correct? We will even verify the negative sign here. Is negative sign supposed to be here? We'll verify both the value as well as the sign. Okay, first let us verify the value 37. Now look here, should the image be, the image is from here on the ray diagram, the image is from here. Now tell me, at what value is this point? This value is at 30 centimeter, is it not? 30 centimeter. So this one, okay, this one we are getting to be 37. So is this correct? Yes, it is correct. Okay, so till this much is 30 centimeter. We are measuring from here 0, then 5, 10, 15, 20, 25, 30, and like that 37. It goes on like that. So it's correct. Okay, so this is the correct position. Okay, so the ray diagram will also justify with the answer. So the justification is done. So the value is correct. If you are getting the image here, then it is wrong. If you are getting the image here, that means it's between C and F. That means it's below 30. So wrong image. It should be here. it should be more than 30. So getting this answer is correct. Okay, then what about this minus? This minus, you are getting this minus because if you are to measure the image distance, how will you measure? Would you not be going like this? Yes. So your direction along with the direction of light, you are going opposite to the direction of light. When you go opposite the direction of light, you get negative value. So minus is also justified, value is also justified. This answer is verified and correct. Alright. Now what we have to find? We have to find nature and size. So nature, since you know the case, you can write the nature. Nature will be, what is the nature for this case? Real and inverted. Okay. So real and inverted. Okay. To leave some space afterwards. Real and inverted. Okay, this is the answer. Real and inverted. Okay, real and inverted. Now what we will do, we will go and find the size. So let us find the size. So let's find the size. To find the size, remember the three formulas of magnification. Let me erase this one now. So we have magnification formula is equal to minus v by u. Let this be equation 1. We have magnification formula equal to hi by ho. This is the second formula. From 1 and 2, from equation 1 and 2, we get another formula which is minus v by u, giving us hi by ho. This is the third formula, and we will be using the third formula. Okay. Now, why didn't I use the second formula? Now see, ho is given to me, so you may be thinking, sir, we should use, of course we can use this also. Okay, so we have this ho, we don't have hi, we also don't have m. So in this formula we have two unknown quantities. Out of three quantities we have two unknown quantities. So that's the reason why I'm not using. Of course I can find the value of m from this equation 1 and do it. If you do like that, the answer will still be correct. Okay, but I will be using this third equation. Okay, this is more easier. Okay, I don't want to go searching m and then bring it back and do like that. So at one go I want to finish it, because time is also a very big factor in exam. Okay, most students, they don't get enough time. Okay, so time is a big factor in exam. Nobody gets extra time. You only get that 3 hours, so you have to finish everything, go for revision and check for mistakes. So time is a big factor. I will go for third equation. Okay, now using the third equation, so minus v by u is equal to hi by ho. Put the values, minus from the formula, and our own value of v has got minus, which is minus 37.5. So minus 37.5. Then u value minus 25, isn't it? Yes. And this is hi. We don't know hi. We are supposed to find hi. Ho, how much is it? 4. This is 4. Okay. Minus from the numerator, denominator, you cancel it. You're getting this. So what you got, you write them down. 37.5 you have here, and you have 25 here, and you have hi by 4. In the next step, we will remove the decimal. So if I remove the decimal, then let me make some room here. So if I remove the decimal, it will look 37.5. Decimal is gone, so it will be 375. And denominator will get 10, so it will be 250, isn't it? And then this will be hi by 4. Let us simplify these numbers. Let's convert them to the lowest term. Let's cut by 5. So 5 5s are 25, 0, 5 7s are 35, 36, 37, 2 in hand goes here, 5 5s are 25. Remember, don't forget the minus. Okay, 5 10s are 50, 5 1s are 5, 6 7, 2 in hand, 5 5s are 25, 5 2s are 10, and 5 3s are 15. Now though we cannot cut anymore, so write down whatever is left. Minus 3 by 2 is here, and you have hi by 4. We will be doing cross multiplication again, reminding again not to write this with pen. You can do it with pencil and also erase it. So 2 will pair up with hi, and minus 3 pairs with 4. Hi will remain here, minus 3 into 4 there. 2 will go below them. 2 2s are 4. You are left with hi is equal to minus 3 into 2. So hi value is how much? Minus 6 centimeter. This is the answer of this is the size of the image, okay, minus 6 centimeter. This is the size of the image. Hi represents the height of the image. Height of the image is synonymous with size of the image, okay. So this is the final answer. If we have a look at the object height and the image height, we find that the image is larger. So even the ray diagram should justify that. See, this object height is 4, this is 4, and image is 6. So see here, so correct, okay. Even the ray diagram is justifying that the image is enlarged. So here we're getting a enlarged image. The object is smaller, whereas the image is larger. All right, so this is it, class. We will end the video from here. Okay, so this is the complete answer. So I'll see you again in the next video. Okay, until then, take care and God bless you.